Hello, I'm Dan Fitzsimmons, and I'm here today to demonstrate the Piccolo Chinook for you. The Piccolo Chinook is the smallest in our line of coffee roasters. It'll roast batch sizes as small as 200 grams and as large as 4 kilos. Very scalable, and it scales automatically depending on the parameters that you select prior to roasting. We are starting with a cold roaster. It's the first roast of the day. I thought you might be interested in seeing how that works. So the first thing we're going to do is turn on the coffee roaster. And when we do, it'll go through the boot up sequence with the computer, do some housekeeping, and then let us know it's ready by turning on the light in the roasting chamber. So I'm applying the electricity now, the 3-phase power, and we'll see the light come on momentarily here. Okay, we're ready to roast. So now it's just a matter of starting up the control console. So the control console runs on Windows 11. It's a full screen console. You can operate the console in close proximity to the Piccolo or anywhere else in the local area network. If you have a Windows computer with the appropriate software, you can monitor the Piccolo and what's happening and so forth. Or if you have a larger half bag roaster or even a larger Chinook roaster, you can monitor that from other locations. It even allows you to broadcast your video if you wanted to broadcast it over YouTube or some other method for people to see what's happening real time in the broader wide area network. So we're going to initiate the control console right now, and you'll see it come up on the left screen. We're ready to start roasting. I'll explain what's happening as the roast is progressing, but to save time, we'll load up the coffee roaster right now. So I've got 2.5 kilos of a blend of coffee. It's one we call Afro Java. And we've developed a roast recipe that allows us to pre-blend. So it's a very efficient process in terms of use of your time and so forth. Now, we have two ways of controlling or specifying the parameters that you might call a roasting profile or a roasting recipe. One is the manual way that you would use if you were starting up from scratch with a brand new single origin or a brand new blend. And the second way is a recipe system where the files are all pre-made, filed away for rapid selection in a production environment. So we're going to use that latter method today for expediency, but there'll be another video where I go through the other method of constructing the recipe very efficiently using various steps in the control console. So at this point, we will select this button up here, which is the recipe on file. When I do that, a window will open, which will allow me a selection of coffees. And as you can see as I scroll through here, there are quite a few different blends and single origins that we've set up for use with the system. Now I'm going to scroll down to Afro Java, which is also known as TCR06, and I'm going to select 2.5 kilos at medium dark roast. I do that, and the parameters are filled in here so that I know exactly what I'm dealing with. It indicates the weight of the individual coffees that are involved with this blend, and also some descriptive information regarding the roast recipe and what the user can expect from the coffee once it's completed roasting. So at this point, we've got the coffee roasted, we have the coffee loaded, and so now it's simply a matter of clicking the green button in the upper left-hand corner here to start the roasting process. Now the Piccolo is a single modular unit. It comes fully assembled. It's ready to plug in, slide underneath your chimney, and start roasting. In the Piccolo, at the very base, is a blower which produces all the airflow for levitating the coffee. In the middle is a heater, a very precise heater that listens to the computer and reacts instantaneously to change the temperature of the roasting air. And you'll see that develop in the roasting graph during the process of this batch. And at the top is a air box where the heated air goes in, spreads out, so that it can levitate the beans across the face of this air curtain here. So you see the beans are being levitated, and they fall back and slide down, and then they're levitated again, fall back and slide down. It's known as a rotating fluidized bed. It's the process that Mike Civitz patented in 1976, and it's the process on which we base all of our roasters because it's the most efficient air roasting process. One of the big advantages of this design is that it allows you to separate any extraneous temperatures or temperature influences from the bean temperature so that the bean temperature can be measured accurately. And the reality is, in engineering parlance, if you can't measure it, you can't control it. And there are so many roasters out there where, well, in fact, most of the roasters have an imperfect method of registering the bean temperature. And that being the case, it's your most important parameter. And if you can't measure it, you can't control it. So the bean temperature is measured, or it's accessed by the computer 10 times a second. And then the computer goes through some calculations and tells the heater how to behave. So the heater is given instructions 10 times a second with an indication of how much heat it should put into the air. Now, during part of this process, I'll give you some up-close shots with screen capture on the control console, and we'll talk about that a little bit. Now, my work here is done. The Piccolo is designed to allow the owner to work on the business, not in the business. So the owner would come around, load it up like I've done, select the recipe, start the roasting, go away and do their invoicing, do their packaging of the previous batch that they roasted, do any number of things that help them conduct business efficiently. But there's no need to sit here and watch the roaster. The roaster will take care of business all by itself, and when the roast reaches its target temperature, it'll cool it down to 200 degrees, then open the door and evacuate the beans into the cooling tray. At that point, the fan in the bottom of the cooling tray, which is wired directly to the bottom of the Piccolo, will immediately start up and start pulling cooling air down through the beans. So when the operator comes back to the roaster, the beans are cool and the roaster is ready for the next batch of coffee. So I'm going to disappear, let this complete, and we'll come back and take a look at it a little later.
So let me talk about this for a moment. If we take a look at the screenshot here, you'll see the graph shows two lines. These are the two most critical lines in relation to roasting coffee. The brown line is the temperature of the bean during the process. So this roast batch took 8 minutes and 39 seconds to roast, and the brown line graph shows the way the bean temperature behaved while the heat was applied to it, the roasting air heat was applied to it. Now, if you look at the red line, you'll notice there's a hump in the first 2 minutes. We refer to that as accelerated drying, and that can be turned on or turned off, either manually or automatically using our between batch protocol. So you can see that the accelerated drying applied heat very aggressively, and hence the rate of rise of the brown line is much greater than immediately following the reduction in heat of the red line. So the reduction of heat occurred when the bean temperature exceeded 80 degrees, according to the setting that we had for the end of drying stage. Once the end of drying stage was completed, then control of the heat was turned over to the bean/air temperature differential target. That is the number of degrees that we want between the bean temperature and the heat that's being applying to the beans. So you could think of it as in a measure of intensity. So if we increase that, in this case the number is 45 degrees. If we increased it to 55 or 65, the duration time of the roast would be shortened and the flavor would be more complex. The interior of the bean wouldn't be roasted as completely as the exterior, and that would affect the flavor. If, on the other hand, we drop the temperature from 45 degrees to 35 or 30 degrees, then the roasting batch would take longer. The flavor would smooth out, there would be less complexity and more body. So this is a critical parameter that allows you to control the duration of the roast time, and hence the degree of difference between the internal roasting and the external roasting, which you can determine using an Agtron or a Light Tells or some other near-infrared measurement device for measuring the ground coffee and the roasted beans. So each vertical line is 1 minute, so it shows you the elapsed time. So as I indicated in the upper left, it was 8 minutes 39 seconds that it roasted, and the cool time was 1 minute and 12 seconds. That's the time from when the heat shut off to the point at which the beans drop down to 200 degrees, and that's important because we have the evacuation set at 200 degrees. So when the coffee drops down, after roasting, when the coffee drops down to 200 degrees, the door automatically opens, the cooling fan comes on, and the beans evacuate into the cooling tray. So there you see it. It's pretty straightforward. And if you pair this visual and the parameters with feedback from a near-infrared roast color analyzer to check the roasting of the internal coffee bean and the external surface of the coffee bean, you will quickly develop an intuitive ability to determine the parameters that you want to implement for any given coffee to achieve the flavor at the end of roast. Now, of course, you have to roast and taste and roast and taste, but the important thing is if you achieve a particular taste from a roast, you only need the bean target temperature and the bean air temperature, roasting air temperature differential to achieve that again in a subsequent roast. So it makes it very easy, the Piccolo makes it very easy to return to whatever roast you've determined elicits the best flavor.
Okay, the roasting is just about finished. I'll take a look at the bean temperature. The bean temperature is 226 degrees. You might be able to see here the red line is dropping, so the heat is shut off and we're cooling the beans down. Now, the beans are at 224 degrees right now, and as soon as they cool down to 200 degrees, the door will open, they'll cascade out into the cooling tray, and simultaneously the cooling fan will start up and start pulling fresh air down through the coffee to cool it off quickly. So as you can see, there's been no need for an operator to stand here and look at things and make sure the roaster is doing the right thing. Very dependable, consistent, trouble-free. We're down at 205 degrees, and here we go. Now it's taken a little over 1 minute to cool the coffee down to 200 degrees so it could evacuate. I could have come back at that point in time and loaded the coffee beans up for the next roast so that while this is cooling, the next batch should be roasting. So now we're finished, ready for the next batch to roast. Now I'm going to adjourn to the studio and overdub some information as we go through the period of time when I was not here, and we'll take a look at the roasting recipe and the control console chart as it was developing, and I'll explain some of the parameters that are in effect that determine how the coffee is going to be roasted and how it's tasted.